Problem number 20 says an isosceles triangle has a base along the x-axis with one base vertex at the origin and the other vertex in the first quadrant on the graph. Y equals 6 minus x squared. So, first thing I'm going to do is I'm going to draw my xy plane. Okay? And it says, let me read it again so you guys can hear what I'm saying. It says that an isosceles triangle has its base along the x-axis with one vertex at the origin and the other in the first quadrant. So this is, and let me draw it in a different color. What they're saying is that my base of my isosceles triangle is right there. Okay? And then it says, with its base at the vertex and at the origin and its vertex in the first quadrant on the graph, y equals 6x squared. So they're saying that the vertex of this thing is at 6 minus x squared. So you guys should know this off the top of your head, but this has a y-intercept at y equals 6, and it's an upside down parabola. Now, if you didn't know that off the top of your head, the first thing that you would need to do is graph it. So that's what we'll do, is we'll come in and we'll graph it. And we will look to see, because it says the vertex of this thing is on this graph. So now let's look at what that looks like. So if I say 6 minus x, x squared, and I graph it, I'm looking at this right here. So this curve comes down around like this. All right? And so it's an isosceles triangle. I'll try to draw it to scale as best I can. So that's my isosceles triangle. Now, what is the height of my isosceles triangle? Because what it tells me to do next is write the area of the triangle as a function of the length of its base. Well, the area of this triangle is 1/2 times the base of the triangle times the height. And the height right here is really the y value of this function evaluated at x or whatever this is. So we can find this height, which is equal to 6, oops, I got to pull that back up on the screen. 6 minus x squared. The problem is I don't know what x squared is. Okay? But my base would be from here to here, right? So could I say a is equal to 1/2, my base is x, and my height should be this number? No, because where would this x value be? So it's kind of like this, but I got to change it up a bit. So if I make this x, what would I call this x value right here? Wouldn't it just be 1/2 x? Wouldn't this be 1/2 x? Whatever I plug in for x, this corresponding x value that will calculate the height, wouldn't it just be 1/2 x? Does that make sense to you guys? Oh wait, I did that wrong. It doesn't go there. But my height would actually be 6 minus x divided by 2, all that squared, right? I'll give you a second to kind of let that process. So what I'm saying is that this triangle, and I'm going to draw it out separately. The distance, we assume that this is 0 and we go out to x. Now, I have a curve that comes through the vertex like this. This point right here should occur at 1/2 of x, whatever I choose for x. And then the distance should be my y value, evaluated at x divided by 2. Well, this distance from here to here, the y value, y equals 6 minus x divided by 2 squared. Does that make sense to you guys? So now I just got to clean this up a little bit. So I got to say 1/2 x times 6 minus x over 2 squared. What would be nice is if I knew the x value. Is there a way that I could find the x value? Let's think this through a little bit. Is there a way to do that? Is there another way I could calculate the height of this thing? Well, what if I did this? What if I said that y was equal to, what if I expanded all this out and tried to put it together? Because really, we would say that y is equal to, and I'm going to change the value from x to b, right? Because the base is really b. So I'm going to say 6 minus the base squared over 4, right? Because I'm going to make this equal to b. See, the problem is in order to ensure that this crosses through the graph, I can't go over too far, right? So if I graph this thing, I can't just arbitrarily choose x, because if I choose x way over here, then I'm not guaranteed that the vertex is going to stay on this curve. Does that make sense? So I really gotta solve this thing and figure out some parameters. So I'm going to change x equals b because I'm afraid you guys might get confused. Now the problem with this is that's a little messy. So I'm going to give them a common denominator. Alright, and I'm going to change the color too. So what I really want to look at is I want to say y is equal to, now if I put this over 1 and I multiply both the top and bottom by 4, I get 24 minus b squared all over 4. Does that mean the same thing? In other words, this right here should be b over 2, comma, 24 minus b squared all over 4. That's really what that point should be. So now if I think of it in terms like that, I would say that the area, which was equal to 1/2 times the base times height, would be written as 1/2 is equal to 1/2, or the area is equal to 1/2 times the base, and now the height is all this stuff, 24 minus b squared all over 4. It's the same thing, it's just written a little different. Well, I know that this point right here is b comma 0. Right? So that point has to be b comma 0 because that's the length of my base, right? That's the base of this triangle. Well, let's clean this up a little bit. If I take this and push this through, I get a is equal to, the 1/2 goes through, and I get 24b minus b cubed all over 8. Well, that's the area. Now, what could I do with the b's? Huh? I could change them to x. It'd be the exact same thing. Did we solve what the question was asking us?
Yeah.
Now, why did Mr. Adams switch it to a b? Yeah, because technically it said the base. Now, I could leave it as an x. In other words, if I wanted to think of it in terms of the xy plane, it'd be the same as saying the area is equal to 24x minus x cubed all over 8. Now, there's a domain restriction on that. We can't have an x that's way too big or way too small, because then it won't work. So how would I find that domain restriction? Well, the question doesn't ask that. So let's just think about that. Are there any questions on this one?